Hi, this is the video solution to example sheet 1. Example sheet 1 is about introduction to R, which is a free statistical software. So in this video, I will talk about some basic concepts of R. So it's based on So this video is based on the following tutorial sheet. Let me show you this one. This is the tutorial sheet this video it will be based on. So I will just go through this tutorial sheet and explain things to you, right? Okay. All right. To start with, the first thing you need to know is how to start using R. In my laptop, I already have R installed. So all I have to do is I go to the Start button and go down the menu and then click on this. And there are two options, either the 64-byte version or this version. The 64 one is the more powerful, so I will choose that one, right? And it will come up with this window here, and this is the R window. But in your case, you may not have R installed on your laptop or the PC that you have at home. So what you need to do is the following. Let me show you. Just open a browser, whatever browser you have, right? And then type the following URL, www.r-project.org, right? Press enter, and it will come to this. And here you click on download R, then you get to this. Now these are mirror websites, so you go to the one in the UK and you choose. There are two options. There's the one at Bristol or there's one at Imperial College. You can choose either of the two. So let me choose the one in Bristol. Then you will get to this. All right, there are three options. You can download, depending on the operating system that you have at home, either Linux or Mac or Windows. You can choose one of these three. I have Windows in my computer, so I'll click on this, right? And now if you're using R for the first time, I think most of you will be that. Most of you will be using it for the first time. You will click on this, and as soon as you click on this, it will take you through a process, and you'll be able to install R to your laptop or PC. All right. So it's a very simple procedure on how to install R. I don't need to do this because I already have R installed in my laptop. Okay, so I will close this window. All right. So this is what you have. All right. After installing and after opening R, this is the window that you will get. All right. So now let me show you some pretty basic stuff like adding and subtracting and so on. So for example, 33 plus 24 minus 8 is 49. So it's very easy to do simple calculations using R. 25 multiplied by 20 is 400. So you use the simple star to denote multiplication, right? 2786 divided by 256 is this. Right, so you use the backslash to denote division. This means 4 power to 3, so 64. 4 to the power 3 is, so use this symbol here to denote to the power, right? And you can have something like this too. This here. So here you have 2 plus 4 times 20 divided by 10. So when you compute something like this, what R does is it does the multiplication first, and then the division, and then the sum with 2. So the answer is 10. R also has the number pi, which is 3.141 up to the first 6 decimal places. So for example, if you want to compute pi times 10 power 2, that will be 314.1593. Okay. All right, now how to make assignments in R. Like if you want to, if you do something like this, right? That what this means is that you are assigning the value 23 to an object called A, right? So in this case, these two signs, is, the less than sign and the dash sign, they represent the operation of assignment. So whenever you want to assign something, assign a value to an object, you need to use this the less than sign followed by a minus sign, right? So that is these two signs together represent the operation of assigning a number to an object A. In this case, the object is named A. All right. So if you type A now, you see A is equal to 23. And similarly, you should do this. What you're doing is you're assigning the value 5 to an object called B. So if you type B, you see that B is equal to 5. Okay, now if you type A times B, it takes the product of the two values, 23 and 5, which is 115. And if you type A divided by B, it divides 23 by 5, which is 4.6. Now if you do this, right? So here you're multiplying A with 10 and adding the value B, and then assigning whatever result that you get here to an object called C. So C, in this case, will be 235, because it's 10 times A, which is 23, plus B, which is 5. Okay. Now this command ls means list. So let me, ls means list. So it basically lists all the objects that you have created so far in your session. So the objects that you have created so far are A, B, and C. By the way, this number symbol is used to denote comment. So you can write anything after the number just to tell people what you're doing, right? So this is a comment, for example, right? All right, so you can use the number symbol and write whatever you like, right? And RM stands for remove. So once again, if I want to explain what RM means, I will use the number symbol, then say RM means remove, right? So what it does is it removes the objects A, B, and C that you have just created from the session. So now if you type ls one more time, you see there are no objects left in the session, because you have removed all 3 objects that you created. All right. Right. One other thing I need to say is that R is case sensitive. So like here, I assigned the value 5 to the object X, small x, but capital X is different, right? In other words, the small x and capital X are not the same in R. right? Okay, so you must be careful, right, not to confuse the small letters with the capital letters. They are taught, right? They are not the same, right? Now, the next thing I'm going to talk about is how to create vectors. Now, to create a vector, you need to use the sign C. Then in brackets, you need to type in the numbers, right? So in this case, let me do this. All right, so what I have done here is I have created a vector that contains the following numbers, 1.4, 2.7 up to 16, right? So it's a vector containing all these numbers. Okay. Now I can do standard things with vectors. So for example, if I multiply x with 2, this is what you would get. So every number in x is multiplied by the value 2, right? If I multiply x with 2 and add a value 1, then this is what I get. So a 1 is added to every number in this, right? And if I do this, I get this. So this is 1 divided by x. So for example, 1 divided by 1.4 is this, and 1 divided by 2.7 is this, and so on, right? Another useful command is length. So the length gives you the number of data points in the vector. So in this case here, there are 9 data points. So the length of x is 9. Another useful command is sort. Sort, it sorts the values in increasing order, right? So it sorts the values in x from the smallest, which is 1.4, to the largest, which is 16. Another useful command is square root of x. So square root of x basically take the square root of every number in x. So this is the square root of 1.4, this is the square root of 2.7, and so on, right? Sum of x, it simply computes the sum of all the values in x, right? Mean of x, it computes the mean or the average of, so it takes the sum of all the values in x and divides them by the total number, which is 9. So that gives you this 8.63333. var of x computes the variance. If you look at the notes, I gave you a formula for computing a variance of a data set. So that formula is used to compute the variance of the data here. Okay. SD of x computes the standard deviation, right? So it computes the standard deviation of the data over here, right? You can also compute the standard deviation by taking the square root of the variance, right? So that, you see, that gives you the same answer as SD of x. Because standard deviation, as you may recall from the lectures, is the square root of the variance, right? Another way to compute the standard deviation is to use the formula that I gave you in the lectures, right? Which is the following. It will take me some time to write it. All right, this is what you get, right? This is, you may recall, this is one of the formulas I gave you in the class for computing the sample standard deviation. Now you should type S, so you get the same answer as here, right? Okay, and you can type S squared. S squared will give you the variance, which is the same as what we got here using the var command, right? Okay. Now, if you type ls one more time, it will list the objects that you have created so far. So you have three objects: S, the standard deviation; V, the variance; X is the original data set, right? Now, okay, let me retype X here. X is a vector containing 9 elements. Now, suppose you want to pick a particular element of X. So suppose you want to find the third element in X, which is 1, 2, 3, right? 1, 1, 2, 3. The third, so which is 4.9. Right? Now, suppose you want to remove the third element from the vector. That will give you this. So it removes the third data which is 4.9 from the vector. So it gives you this. Now, suppose you want to take all the data from the second position to the fifth position. So this is the second data set, third, fourth, and fifth. So that will give you 2.7, 4.9, 5.5, and 7.8. Okay. Now, suppose you want to pick the last three data points in the vector. So that will be 14.2, 15, and 16, because remember, length is 9. 9 minus 2 is 7. So this is in the 7th position. This is the 8th position. This is the 9th position. So all the data is from the 7th to the 9th position are here, right? And this command gives you the data in the 2nd, 4th, and 8th positions. So the 2nd is 2.7, the 4th is this one, and the 8th is this one, right? So these are the data that you get. Now, suppose you want to find the values in X that are greater than 12. So there are only 3 values that are greater than 12, namely these 3. So that's what you get here, right? And suppose all right, let me explain what this is. This is all the values in X such that X is less than 2 or greater than 15. This vertical line here means or, right? It means or. So X is less than 2 or greater than 15. So once again, there are only 2 data points that are less than 2 or greater than 15. There's 1.4, which is less than 2, and greater than 15, there's only 1 data point, which is 16, right? So that's what you get. Now, right, this one. What this means is that all the data in X such that X is greater than 6 and less than 12, right? So there are, once again, there are only 2 data points that are greater than 6 and less than 12. So if you go back to the data again, there is 7.8, right? Okay, it satisfies that, and 10.2 also satisfies that, right? Okay, now let me retype X here. Now there are also logical vectors that you can create. Now if you type X greater than 5, this is what you will get. What you will get is a vector with true or false. So basically it will tell you like which of these numbers are greater than 5, and if they are, then you will get true, and which of them are not greater than 5. If they are, then you will get false. So for example, 1.4 is not greater than 5, so it is false. 2.7 is not greater than 5, false, whereas 16 is greater than 5, so it's true. So it's a vector of true or false, depending on if the condition is satisfied or not, right? So if I type LV, right, then LV will contain this vector here, containing false or true, okay? Now, there is a big difference between this statement here and the following. Right here the result will be either true or false, depending on whether this is satisfied or not. Whereas here, this one here, it gives you the value of x such that x is greater than 5, right? So these are the values where x is greater than 5, 5.5, 7.8, up to 16. So you see there's a big difference between this. This gives you true or false values, whereas this gives you numerical values, right? Okay, so let me now let me just explain and give you some symbols used in R. So this sign here means less than, right? Okay, and this sign here means greater than, and sorry, this one means less than or equal to, right? And this one means greater than or equal to, right? And if you have a double equal sign, that means equal to. And if you have something like this, an exclamation mark followed by equal sign, that means not equal to. And if you have this sign here, that means and. Okay, if you have this sign, that means or, right? And if you have the exclamation mark, that means negation, or not the same, not of whatever you have, like, okay, so like for example, the exclamation mark followed by equal means not equal to, right? So these are the common operators used in R, okay? All right, next, let me talk more about true or false things, right? Suppose C1 is a vector containing two values, true and true, right? And C2 is a vector containing the values true and false, right? Now, if you type C1 and C2, I'm sure you guys have done Boolean algebra. The answer will be true and false because it's done element-wise. So the first element of C1 is true, the first element of C2 is true. So true and true is true. The second element of C1 is true, the second element of C2 is false. So true and false is false, right? Whereas on the other hand, if you type C1 or C2, this is what you will get, right? True or true is true, true or false is true. So this is the result, all right? Now, let me type LV one more time. LV is the vector that contains these values, right? Now, if you type sum of LV, what will happen is this: you will get the value 6. The reason for that is because it counts the false as being equal to 0, and it counts the true as being equal to 1. So there are 3 false values and there are 6 true values. Therefore, the sum is equal to 6. Right? All right. Now remember, x is this vector that we created earlier. Now x greater than 14 is a true or false vector, right? Depending on whether the number is greater than 14 or not. There are three values which are greater than 14, and the remaining are not greater than 14. Now you should type sum of this. You will get 3 because the false values are taken to be 0 and the true values are taken to be equal to 1. And there are only 3 true values, and therefore the sum is 3. Right? All right, now let me go to exercise 1, so if you return to the example sheet or the tutorial sheet, this is the first exercise that we need to do, exercise 1. So let me go through this quickly as possible, right? So you have these 2 vectors y and z, right? And we need to compute these things here, right? So this is, I'm going to start with exercise 1, right? So the first thing we need to do is to create the vectors y and z. So y is 1, 2, 4, 12, 16. And z is 3, 4, 8, 9, 15, 18, right? So you have these 2 vectors, y and z. So the first part of the question is to compute y minus 3. So what it does is it takes away 3 from each value in y, right? So you get this, right? And the second part is to multiply z by 3 and add a 1, right? So you get this. So you multiply every number here by 3 and add 1, all right? The third part is to compute the median of y. Once again, if you look at the lecture notes, I gave you formulas on how to compute the median of a data set. So if you use that formula for the first data on y, you will get this, and for the data on z, you will get this. All right. The next part is sum of. All right. Here you get 33 because it computes the sum of all the values in z which are greater than 10. All right, so that's basically the sum of 15 plus 18, which is 33. Right. The next is mean. All right, the mean of the values in y from the 2nd position to the 4th position. So that is all the values from 2, 4, and 12. So the mean of these 3 numbers is 6. Right. The next one is mean of all right. Here we are looking at z, but we are removing all the values from the 4th position to the 6th position. So the 4th position is this number, the 6th position is this number. So we are removing the data values 9, 15, and 18, and then taking the mean of the first 3 numbers, which are 3, 4, and 8. And the value that you will get is 5. Right? The next is y plus z. It doesn't work. The reason for that is because, all right, let me read. The reason for that is because the y and z are of different length. Y is of length 5 whereas Z is of length 6. And I'm sure you guys know that you cannot add vectors that are of different length. They must be of the same length. So this operation is not valid, right? Y plus Z. Right. The next one is sum of y greater than or equal to 4. That gives you the value 3, because here you are summing, you're checking to see which of the values of y are greater than or equal to 4, right? And counting the number of values of in y that are greater than or equal to 4, right? So there are only 2 values in y that are greater than or equal to 4, this one and this one. Sorry, there are 3. Sorry, the 4, 12, and 16. There are 3 values that are greater than or equal to 4. So the sum is 3, right? And this is very different from, I think I mentioned this before. This command is different from this one, because here you're summing the values of y that are greater than or equal to 4, which is 4 plus 12 plus 16, which is 32. Whereas here, you're counting the values of y that are greater than or equal to 4, which is 3. So these two, once again, these 2 commands are 2 different things, and you must be careful. And finally, this one, right? Here, once again, you're checking to see how many of the values in Z are greater than 5 and less than 12, right? And it says there are 2. I mean, that's clear, right? Okay, there are 2 values, and there are 2 values in Z. This is Z, that are greater than 5 and less than 12, namely 8 and 9. So it gives you the number of values in Z that are greater than 5 and less than 12. So that completes exercise 1. Now let's go back to the tutorial sheet. So we've done exercise 1. The second exercise is this one, right? So you got this data set. The first part is to enter the data set into R, right? I will do that now. So exercise 2, right? So the first thing we need to do is to enter the data. So this is how you do it. So it's 38, 42, 44, 43, 46, 48, 52, 54, 50, 47, 40, 48. So this is the data that we just entered, right? The second part is to find the minimum, maximum range, means, and the standard deviation of the data. So rather, to find the minimum, you use the command min, right? To find the maximum value in the data, you use the command max. To find the range, remember the range is the difference between the largest data value and the smallest data value. So it's simply max minus the min, right? And mean, to find the mean, use the command mean. And to find the standard deviation, you use the command SD, right? Okay, so that's done. In the third part, we are told that the first value is actually not 38, but actually equal to 48. So how can we change? All right, now I mentioned to you before, to pick out a certain value in the data set, right? So for example, if you want to know what the first data value is, you do this, right? So that's the first data value in the data set. Now we want that to be equal to 48, not 38, right? So you do this. Now if you retype S, you see the 38 has changed. The 38 has changed to 48, right? Okay. Right, so that's the Next part is to, based on the corrected data, find the percentage of days with the closing price less than 45 pence. So we want to know what percentage of these values, right, are less than 45 pence, right? So basically you need to, all right, this object here, it gives you the values in S that are less than 45, right? Now if you do this, right, then it computes how many of the values in S, right, are less than 45, right? Or you can also do it without, if you want, you can also do it like this, right? You should type length of, I think it's better, right, better do it like this, okay? But I think it's better this way. Is to compute the values in S that are less than 45 and then take the length of it, right? Right, and then divide this by the actual length of S, right? Right, and then multiply by 100. So that will give you the percentage of the number of days, or a percentage of the time that the closing price is less than 45. I hope you guys follow this, right? This, by the way, this gives you the values in S that are less than 45. And when you take the length of it, it gives you the number of days when S was less than 45. And you divide that by the total number of days, right, which is this one. Then you multiply by 100. Okay. That's what gives you 25%. Right. And the final part is to use the diff command. Right. Let me show you. When you use the command diff, what it does is it takes the difference between successive values. For example, -6 here is 42 minus 48 is -6. 44 minus 42 is 2. 43 minus 44 is -1, and so on. So it takes the difference between successive value. And if you look at the length of the object, it is 11, which is 1 minus the original length of the data. That's because when you take the difference, you leave out you take the difference between the second and the first, and the third and the second. So whatever excuse me, whatever you get here is one minus the original length of the data. The original length was 12, and 1 minus of that is 11, right? Okay. Next, all right. Next, I'm going to show you how to read data from a file. How to read data. So suppose if you let me open a window. I'll show you. And let's go to the course website, which is this is the course website, right? And there is a data set which is called Moses, and this is the data set. Now, if you want to read this data set, what you need to do is the following: just copy the URL, right? And go back to the R session and paste it here, right? Right, and then say header equal to true, right? Because you remember that when it has a heading, which is, you don't want to read the heading. You just want to read the numbers, not the heading. So for that reason, you want to say header equal to true, right? And then you assign it to an object. Let's call it Moses. You can call it any other name you like, right? Okay, so it's red. Now if you type Moses, right, you see the data set. There are two columns to the data. The first column is just a counter column. The second column is the time, right? It goes from 47.58 to 48.90, right? Okay. So if you type Moses $time, it gives you the second column, right? So you have to use the $sign to pick out the column. So in this case, you just have one column. Sorry, excuse me again. You just have one column apart from the first column, which is a counter, and the title of the column is time. So whenever you say Moses $, the title of the column, it gives you the values in that column, right? Which are these ones, right? Okay. Now let me explain something about categorical data. All right. Before I go to that, there is an exercise on page 8. So if you go to page 8 of the tutorial sheet, this is this one. Is this one here? Yeah, there's an exercise here which says for the Moses data, calculate the minimum, median, and maximum times, and what proportion of the times are less than 47.5, and what proportion are greater than 49.5. All right, let's do that now. Okay. So we want to compute the minimum, which is just simply min. Sorry, it's simply min of the data, right? To compute the median, just say median. Okay. To compute the maximum, you just say max. Now, it's asking to what proportion of the times are less than 47.5 seconds, right? So to do that, you do the same thing as before. You find the length of the values in the data, right, that are less than 47.5, okay? And then you divide this by the length of the whole data set. All right, so this is the proportion, right? So there's approximately 8.19% of the data set that are less than 47.5 seconds. And we also want to find out what proportion are greater than 49.5 seconds. So for that, you just simply change the sign here to greater than 49.5 seconds, which is this. All right, so this is approximately 11.48% of the data values are greater than 49.5 seconds. The next thing I want to talk about is categorical data. Sometimes you have data like yes or no, right? Answers. So suppose you have the following data. Sorry, response. You have yes, yes, no, yes, no, No. Yes. No. Yes. Yes. No. Right. So this is the data that you have. So, like for example, if you ask people whether they smoke or not, so the answer will be either yes or no, right? So it's possible to get data set like this, right? Now, if you type table, it kind of summarizes the data. So in this data set, there are 8 people said no, and 7 people said yes, right? Okay. Now you can also have factors. Now, if you type factor, right, and call it response, response f equal assigned the value factor, right, and then you type response f, right, it gives you, so this data is converted into yes or no. 2 factors, one is called yes, or other one is called no without the quotes, right? Okay. And the levels of the factors are yes or no, right? Okay. Now you can change the levels of the factor to some, I mean, instead of being yes or no, you can call it, for example, 0 or 1, like, okay, for numerical purposes. So so what in this case, the no is assigned the value 0, and the yes is assigned the value 1, right? Okay. So this may be useful for, for numerical purposes. So now if you type the response F right now, you will get either 1 or 0, depending on whether it was yes or no. So all the no's are assigned the value 0, and all the yeses are assigned the value 1. Okay. Right, so that's, now finally in this sheet, let's go, there's a final exercise that we need to do, which is this one. We need to read the data from this URL and do the following exercise, right? To read the data, I advise you to go to the website. So this is the course website. It's slow. All right. So this is the data set that we need to read. I don't know whether you can see this, guys, but this is basically a data on the party that people voted for. There are 5 different parties, right? They are Conservative, Labour, Liberal, Democrats, UKIP, or other. So they are coded from 1 to 5. All right, so the first thing we need to do is to read the data. All right, so let me copy the URL and go to our session. Okay, and then read.table. Put this in quotes. Then say header. We don't want to read the header, so we say header equal to true. And let me call this X, or you can call it anything you like. Now, if you type X, you see there are basically 2 columns. There's only 1 column basically, apart from the counter column. So there's a counter column, which is the first column. The second column gives the party that people voted for, is either 1, 2, 3, or 5. All right. So if you type X $party, right, these are the numbers, right? Okay, each person each person voted for one of the 5 parties, right? All right, the question here is to see, is to record the 1 to 5 as a Conservative, Labour, Liberal Democrats, UKIP, or other. So to do that, we just use what we just learned right now. Okay. So let me take you through this slowly. Right now, the factor of X dollar party, right? Okay. Let me call it XF, right? Okay, XF is one of the 5 numbers, right? Okay. Now the levels of XF are 1 to 5. Now we want to record the levels as the actual names. So the actual names, 1 corresponds to Conservative, Conservative, 2 corresponds to Labour, and 3 corresponds to Liberal Democrats. The 4 corresponds to UKIP, and 5 corresponds to other. Okay, so this is what you get now. So if you type levels XF, you get this, right? And if you type XF, you see now you have the data. The data on is not just the numbers 1 to 5, but actually the party names that people voted for, right? Now, if you type table XF, you get this. You see, this table gives you how many people voted for each party. So 369 voted for Conservative, 314 for Labour, 75 Liberal Democrats, 118 UKIP, and 124 other. All right, so when you have categorical data or factor data, these commands that I just talked about are useful, right? Especially the table command is useful to summarize the data, right? Okay, so this completes the video solution for the tutorial sheet 1. Okay. Have a good day, guys.